The serpent that became our teacher, Apophis and humanity's rehearsal for planetary survival. The night we first saw the monster. On the evening of 13 June 2004, astronomers at Kitt Peak National Observatory in Arizona noticed a faint point of light moving against the background stars. Within hours, the Minor Planet Center assigned it the temporary name 2004 MN4. By December of that same year, the automated monitoring systems of the National Aeronautics and Space Administration and the European Space Agency delivered a calculation that stopped hearts around the world. On Friday, 13 April 2029, this 340 to 370 meter wide asteroid carried a 2.7% chance of striking Earth. That translated to odds of 1 in 37, the highest threat level ever given to a known object. For the first time in history, the Torino Impact Hazard Scale reached level 4.
The asteroid was officially named 99942 Apophis, after the coiled serpent of darkness and chaos in ancient Egyptian mythology, the eternal enemy of the sun god Ra. The name felt chillingly fitting. Had the impact occurred, scientists modeled the consequences with grim precision. Energy release equivalent to 150 to 1,800 million tons of trinitrotoluene. Crater 5 to 6 kilometers wide. An ocean strike producing tsunamis 30 to 100 meters high that would reach coastlines in Europe, Africa, and the Americas within 4 to 8 hours. A land strike causing regional destruction 50 to 100 times greater than the 1908 Tunguska explosion.
For 5 anxious years, the world waited while telescopes around the planet tracked every possible arc. The threat finally dissolved on 9 January 2013, when Apophis passed Earth at 14.5 million kilometers, and new observations eliminated the 2036 risk. The absolute end of all danger arrived between 5 and 7 March 2021, when powerful radar dishes at Goldstone in California and Green Bank in West Virginia measured the asteroid's distance to within 150 meters. The closest approach in 2029 was locked at roughly 31,860 kilometers, give or take only 140 kilometers. Every known future encounter, 2029, 2036, 2068, and beyond, now carries an impact probability of 0. The geometry of the Great Encounter. On 13 April 2029, at 21:46 Universal Time Coordinated, 23:46 Central European Summer Time, 17:46 Eastern Daylight Time, Apophis will reach its minimum distance from Earth's center, approximately 31,600 kilometers. That is barely 8% of the distance to the Moon. The asteroid will pass inside the ring of geostationary weather and communication satellites that orbit at 35,786 kilometers altitude, yet it will threaten none of them because its path is inclined 3.3 degrees to the plane of Earth's equator and will slip safely beneath most of those orbits.
From the ground, the sight will be unforgettable. Across Europe, Africa, the Middle East, and Western Asia, Apophis will brighten from magnitude +3.1 to a dazzling 0.5, briefly outshining every star in the night sky. In cities such as Berlin, Rome, Athens, and Cairo, it will remain visible to the naked eye for nearly 2 hours, racing from the constellation Cancer through Leo at speeds up to 5 degrees per minute, 10 times faster than the International Space Station crosses the heavens. Earth becomes a planetary shaking table. At closest approach, our planet's gravity will exert a force roughly 1/500th as strong as the sun's pull on Apophis. That is still enough to transform the asteroid dramatically.
Its current rotation period of 30.4 hours will shorten dramatically, possibly to between 7 and 20 hours. Global seismic shaking, equivalent to magnitude 4 to 6 on Earth, will ripple through its interior. Boulders up to 10 meters across may be flung from the surface, forming a temporary cloud of debris that could produce a brief meteor shower visible from Earth in the mid-2030s. This natural violence will reveal whether Apophis is a solid rocky body or a loose rubble pile, held together only by its own weak gravity. Information we could never obtain by deliberately striking such an object ourselves. The 3 messengers we have sent. 3 spacecraft, built by 3 space agencies on 3 continents, are now converging on the same small world. Rapid Apophis Mission for Space Safety, a partnership between the European Space Agency and the Japan Aerospace Exploration Agency. Launch window: April 2028 aboard an Ariane 6 rocket. Arrival: February 2029. 2 months before closest approach.
Mission: to watch Earth's tidal forces reshape the asteroid in real time, recording quakes, landslides, and ejected boulders with cameras, laser altimeters, and dust analyzers. Origins: spectral interpretation, resource identification, security. Apophis Explorer: the spacecraft formerly known as Origins. Spectral interpretation, resource identification, security. Regolith Explorer, which returned samples from asteroid Bennu. Earth Gravity Assist successfully completed 23 September 2025. Arrival at Apophis, 8th of April 2029, 6 days after the flyby. Duration: 18 months of detailed mapping, dust collection, and surface excavation using thrusters to expose fresh material. Demonstration and experiment of space technology for interplanetary voyage with faith on flyby and dust science. Rescheduled for 2028-2029. A Japanese mission that will either perform a high-speed flyby or linger near Apophis to study the dust environment created by the tidal disruption. Powerful radar installations, Goldstone, Greenbank, and new giant dishes in China and Russia will join hundreds of optical telescopes in a global campaign from 2027 through 2031.
The legacy already written. Apophis forced the nations of Earth to create the International Asteroid Warning Network and the Space Mission Planning Advisory Group. It inspired the Double Asteroid Redirection Test Mission that deliberately crashed into Dimorphos in 2022, and the follow-up Hera mission, now on its way. It prompted the United States Geological Survey to publish, in 2025, the first comprehensive report on cascading hazards from asteroid close approaches, tsunamis, atmospheric dust clouds, and economic shockwaves, even when no impact occurs. The final word from the sky. The latest orbital calculations, combining 2021 radar measurements with thousands of optical observations through 2025, state with complete certainty: 13th April 2029, 31,600 kilometers. 9th April 2036, 37 million kilometers. 19th October 2068, more than 23 million kilometers. Cumulative impact risk for the next century or longer, less than 1 chance in 150,000.